Happy Friday, everybody. Welcome back to the Geology Vlog number 3. Neil S. Turluck, geologist, here to talk to you about the prolific Wolfcamp clay. It is the most prolific shale play in the United States. It's driving the vast majority of the activity in the Permian Basin. The United States Geological Survey estimates that in 2018, the Wolfcamp Formation in the Midland Basin still holds 19 billion barrels of oil, 16 trillion cubic feet of natural gas, and 1.6 billion barrels of natural gas liquids. The Wolfcamp shale was deposited during the early Permian, specifically during the Wolfcampian period between 300 million and 280 million years ago. It was deposited throughout the entire Permian Basin, being thickest in the Delaware Basin at more than 7,000 feet thick, more than 1,600 feet thick in the Midland Basin, and finally up to 400 feet thick in the Central Basin platform. So, I was logging in the Midland and Delaware Basins, very confused when I was in the Wolfcamp A and B. I kept coming across stuff that reacted violently with hydrochloric acid. So the guy who was training me back in the winter of 2016-2017 was telling me that it was limestone, and I was like epically confused. Like, how in the hell do we have a limestone deposited in with a basinal shale? There is no way that this limestone is forming where there should only be clay and what I believe to be a very sediment, clastic rich environment where things aren't going to live. So I was explained by him through him. It was explained by him through him that he knew it was limestone because of the way that the hydrochloric acid effervesced as it reacted with the limestone. He could smell it. He smelled the difference between what would be a carbonaceous shale with like calcite cement or a lot of calcite within it, and limestone. That was his reasoning. I'll never forget that, and it literally drove me insane. I thought the guy was an idiot. So I did some digging around, I did some research, and I found out that it's a lot different. It's underwater gravity flows, kind of like an avalanche. So they're called turbidite deposits, and there is limestone that is sitting on a slope and falling down the slope. The sediments were driven by gravity as they piled up and weighed down on the edges of the basin. As the edges gave way, the sediment fell like an avalanche, depositing a slurry of limestone, sand, silt, and clay that later became the Wolfcamp Formation. The Wolfcamp is known as an unconventional reservoir. It has to be fracked for it to produce hydrocarbons. The porosity, or void space, within the Wolfcamp varies between 2% and 12% porosity and averages 6% porosity. But the permeability is very low, less than 10 millidarcies, which means there is no communication between the pore space and the hydrocarbons that are trapped within the pores. All hydrocarbons are just broken down proteins that didn't have a chance to rot their time. The accumulation of these proteins in sediment are called Kerogen, and is referred to as the total organic content, or TOC. The Wolfcamp has very favorable TOC values ranging from about 2% to 8%. So what does all this mean? It means that the Wolfcamp can make a lot of oil and gas. There is oil present in the cuttings that I collect. If you add lighter fluid to any sample and put it under a black light and wait, you get a ring of petroleum flowing from the cuttings. Chances are, if you frack the Wolfcamp, you will get oil. So I'm betting that you are just dying to know what the Wolfcamp looks like in real life. Well, I have a few examples I'm going to show you from the microscope from cuttings that I collected, cleaned up, and prepared and took pictures of. Also, there was some sort of cave-in, some problem downhole, and chunks the size of my fist were coming up over the shaker table. I collected a few examples, cleaned them up, and I'm going to show those to you too. It's unfortunate for the operating company because we haven't drilled for about 24 hours because the mud essentially turned into peanut butter. But we get a couple of nice examples in hand sample that we get to look at together. Towards the bottom are two pieces of limestone sitting on top of a piece of shale. That's what it stereotypically looks like in the Wolfcamp in cuttings. These are pieces of the Wolfcamp I collected as hand samples that are coming over the shaker table. Very laminated, very shale-like in nature. Here is a small piece of the Wolfcamp under the microscope showing interformational limestone within the Wolfcamp shale itself. And here we have what I see most of is 100% shale, some pyrite occasionally, some calcite inclusions, but it's all silty shale. This brings an end to vlog number 3, the geology vlog, brought to you by Neil S. Turluck, geologist. Tune in, turn on, drop out, and I welcome you to come back for vlog number 4. Thanks for watching. I'll hope to see you again soon.